So here we have a special situation involving inscribed angles. This is in your notes. So an angle inscribed in a semicircle is a right angle. So fill in the blank there in your notes. All right, so here we have an example. An example is in your notes. So the measure of angle ABC is 1/2 the measure of arc AC. Right, we know that to be true because this is an inscribed angle. The vertex is on the circle. Notice that one side of this triangle, right, is the diameter. Right, if the diameter is the side of a triangle, then it's the hypotenuse of a right triangle, and the angle opposite has to be a right angle. So measure of angle ABC is 1/2 the measure of arc AC. We see that arc AC is a semicircle. We know it has to be a semicircle because a diameter divides a circle in half. So this is 180 degrees. So arc AC is 180 degrees, and angle B equals 90 degrees. All right, so you can put that diagram in your notes. Here we have another diagram. It's not in your notes. So the arc of half a circle or semicircle is 180 degrees. Right, we know this is a semicircle. And measures 180 degrees because the diameter AC divides the circle in half. So since AC is a diameter, arc AC equals 180 degrees. It's a semicircle. Right? And that means that since we have a triangle inscribed in a semicircle, that means that triangle ABC is a right triangle. And the angle opposite, angle B, is a right angle. Right? So if you have one side of your triangle and it's a diameter, then the angle opposite is a right angle, equals 90 degrees, and you have a right triangle. And this will always be true. So if you have a triangle inscribed in a semicircle, then you have a right triangle. You can also think of it this way here, as soon as the page turns. So triangles inscribed in a circle. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Conversely, if one side of an inscribed triangle is the diameter of a circle, then the triangle is a right triangle and the angle opposite the diameter is the right angle. So angle B is a right angle if and only if AC is a diameter of the circle. Right, so here, let's call this triangle ABC. Notice that does not go through the center of the circle. This goes from endpoint to endpoint. This is a chord. This one here goes from one point on the circle to another. This is a chord. And this one here, likewise, goes from endpoint to endpoint. This is a chord. Notice none of these chords go through the center of the circle, right? So since none of the none of the sides of the triangle are a diameter of the circle, triangle ABC is not a right triangle. Right, so if you had any confusion about triangle ABC being a right triangle, this eliminates it because none of those are diameters, those are chords. And although the diameter is a type of chord, those chords are not diameters. Let's look at this triangle here. All right, so here we have the diameter of a circle. Oh, let me label that. This is triangle ABC. Right, so there we have the diameter of the circle. So since one side of our inscribed triangle, inscribed, by the way, just means the endpoints are on the circle. Right, so here the endpoints are on the circle, endpoints, the vertices are on the circle, as much as I can draw them. There we go. All right, so since one side of the inscribed triangle is the diameter of the circle, then the triangle is a right triangle. So this is a right triangle, and the angle opposite the diameter is a right angle. That also makes the intercepted arc a semicircle. So the intercepted arc for, boy, it's hard to write there, for angle B, which is arc AC, is a semicircle. Right here, since one side, actually we can label that side, since AC is a diameter of the circle, then the angle opposite AC is a right angle, and triangle ABC is a right triangle. Right, so this one has to be a right triangle because one side of the triangle is the diameter of the circle. And that other one, not a right triangle. Let's do a few problems. And you have one of them in your notes, so the one coming up is not the one that's in your notes. And here it comes any moment. All right, so what do we know? We know angles inscribed in a semicircle are right angles. Here we have the diameter of the circle. That tells us something about arc XZ. And we also know that the sum of the angles in a triangle equal 180 degrees. So let's find all of these. All right, so first of all, let's find the measure of arc YZ. So YZ is right here. Right? If we follow it back, the ends of the angle, so if we follow it, we go down, we go from, so here we are at the vertex at the end of the angle, right? The end point of the angle. If we just follow that back to the other side of the circle where the inscribed angle is located, we see that angle XYZ, or excuse me, YXZ is the inscribed angle for arc YZ. And we know that the arc, we're looking for an arc, equals 2 times the angle measure. So arc YZ equals 2 times angle YXZ. So that means that arc YZ equals 2 times 42. And that means arc YZ is 84 degrees. Right? So we can mark this as 84 degrees. Now let's find the measure of arc XZ. All right, so here arc XZ is going to be should plug in. Thought I did. I'm plugged in, but apparently my charger's not charging. I have that trouble with this one. All right, let me try it one more time. Yay! Okay. Computer won't die. All right, so arc XZ is going to be 2 times, it's also our intercepted arc. We follow it back. We see where the inscribed angle is. I'll just do it in a different color. Here's the inscribed angle for arc XZ. So that means arc XZ is going to be 2 times angle, we could call it angle Y, right? I think it's pretty clear that one's angle Y. There's only one angle there. We could have called the other one angle X and angle Z, quite honestly. Let's just call it angle Y. So that means that XZ, arc XZ, is going to be 2 times. We see the inscribed angle is a right angle. So it's going to be 2 times 90 or 180 degrees. Arc XY. All right, so XY is over here. What color do I have left? I can write it over here. All right, so here's, I'll outline it in purple. Here is XY. We have 2 ways of finding this. Notice we now have every angle accounted for, so we could use the fact that that's the last arc in the circle. Or we could follow the angle back. All right, so no, we will accept we don't have that angle. We could either find that angle first, or we could find the measure of the missing arc first. We're missing both of those things. I guess it doesn't matter which one we do first. May as well find arc XY first, and then we'll find angle Z. All right, so, and then we'll also check and make sure the angles in the triangle add up to 180. All right, so arc XY, let me write in a different color. Arc XY is going to be equal to 360 degrees, the whole circle, minus the other 2 arcs, minus XZ, arc XZ, plus arc YZ. So that means that XY is equal to 360 minus, we've got 84 and 180. So XZ is 180. The other one is 84. I'm running out of space here. So that's 360 minus, so that would be 264. And that means that arc XY is equal to 96 degrees. All right, so now we have the measure of arc XY. And we see if we follow back the red angle there, back to angle Z here has to be equal to half of the arc. So angle Z is equal to half, the angle is equal to half the inscribed arc. So angle Z is equal to half of 96. And that makes, oh, let me write the name of the arc. So angle Z is half of arc XY, which means that angle Z is half of 96, which means angle Z is 48 degrees. Let's see if that works out with, if we add up the angles in a triangle, if that works out. All right, so angle X plus angle Y plus angle Z should equal 180 degrees, because the sum of the angles in a triangle is 180. Angle X is 42 degrees. Angle Y is 90 degrees. And angle Z, we just found, is 48 degrees. And that indeed does equal 180. Right? Because 42 plus 48 that's going to equal 90, and 90 plus 90 is 180, so that does check out. So two ways you can find it. You could have found the angle first and then double it to find the arc, or find the arc and then have it to find the angle. All right, let's do a few more. Oh no, the spinning ball of death. This is the one in your notes, right? And you have all of the words too. So angle B is the diameter of a circle. So arc AB is 180 degrees. All right, so that is 180 degrees. And I believe that's asking about, we want to find the measure of arc AC. Right? We could actually find the measure of BC right away. Then we'll have to find the measure of arc AC. So AB is the diameter, so arc, let's put these in here. Arc AB is 180 degrees. We know that angle A there is 37 degrees. That means that arc BC, right, so that's the arc, and if we follow, probably write a different color. If we follow the angle to the arc, we see that BC is the intercepted arc for angle A. So BC is going to, arc BC is going to be equal to 2 times angle A, which means that BC, arc BC, is 2 times 37, or 74 degrees. All right, so we have this arc here. Now we can find the measure of arc AC, now that we know BC. Let's just put a little arc symbol there. AC is equal to the whole circle, 360, minus the other 2 arcs. So that would be minus arc AB plus arc BC. That means that arc AC is 360 minus 180 plus 74, which means that, I'll have to put it over here, AC, arc AC, is equal to 360 minus 254. So arc AC is, ooh, that just looks pretty bad. I'll write it over here and move it up. Arc AC equals 106 degrees. X is half a measure of the arc. That is an inscribed angle. Arc AC here is 106. So that means that X is going, or angle B, is going to be equal to half of arc AC. Since AC is 106 degrees, X here has to be equal to 53 degrees. Right? So just because it's a triangle doesn't make it any different in finding the inscribed angles. Angles still half the arc. The nice thing is, though, you can also, if you know, so for instance here, since this was a semicircle, this was 180 degrees, this was 90 degrees, and if we look, 90 plus 37 plus, we found 53, does add up to 180. So if you know 2 angles in a triangle, you can also just find the third one using triangle sum theorem. Let's see if we have any more. Or if this was the last one. I don't remember. Yep, that's the last one, because this we're going to look at in the next video. So thanks for watching, and bye for now.